Hi guys, welcome to another video. Today we're doing an Euclidean problem. So this type of a problem is quite interesting. I try to find more complex problems of which we can attempt together. Now you are more than welcome to pause this video and try to attempt the problem yourself, and please leave your feedback in the comments, right? And tell me, what do you think about this question? Did you find it more interesting, or was it boring, so that I can find more interesting questions so we can deal with it? I hope to hear from you guys, and I'll honestly respond to each and every comment that you guys post in the comment section. Let's begin. So we've got a question here, a very interesting one. This is not a common type of a question that we usually get because there's no numbers here, it's only alphabets. No one likes alphabets for some reason. Okay, now let's read the question statement. It states tangent BC touches circle ABDE at B, chords AD and BE intersect at F. Now chord ED is produced to C. Okay, AB is parallel to EC. It is further given that angle B1 is equals to X and angle A1 it is equals to Y. Okay, so the first question of the day is determine the size of angle C. Alright, angle 17.0.1. Now, like I always say, we do what we always do, which is to write Dr. Cape Town. Yes, I know some may be like, how is it gonna help us here? It is most definitely gonna help us. Okay, alright. Now, do we have a diameter here? Did they say anything about a diameter in the question statement? I don't remember, so actually they didn't say anything. Do we see a center here? No, we don't see a center, so let's remove it. Do we have a radius? Obviously, if we don't have a diameter, we want to have a radius, so let's remove it. Do you have a cyclic quad here? Yes. Now, there is a video on this channel that you can check out that has 3 ways of which you can identify a cyclic quad. It's a short, interesting video that I hope each and every student has seen before the exam. You have to see that one video. Alright, so do we have parallel lines? Yes. Do we have a tangent? Yes. So we only have this 3 here, right? So those are the 3 that we have. Now, if there's a cyclic quad, we have to know which type of cyclic quad is it. This is where BBE comes in, right? So BBE, we know that the B stands for what? Stands for the box. So is it a box type of a cyclic quad? Yes or no? You can comment. I'll give you a little bit of time so that you can tell me what type of a cyclic quad is. I'll just keep quiet. Right. I hope you have left your suggestions in the comments and I'll see to them. Right, now, what type of a cyclic quad is this? It's a bow tie of a cyclic quad. So there it is. Yeah, this is a beautiful cyclic quad. So there it is, right? So this is the cyclic quad that we are talking about. So it's the box. It's not an extension. It's a bow tie. Sorry about that. It's a bow tie, not a box. So there's no box. There's no extension. It's just a bow tie. Okay, good. Now let's begin. Let's start to attempt the problem. So now, since we know that it's a bow tie, we know that we're gonna have angles in the same segment. You see how much easier it makes our life, right? Now determine the size of angle C in terms of X and Y. Now a lot of students start to panic when they get here, but don't forget that this is a what? This is a angles in the same segment, and we have these 3 theorems, which is the cyclic quad, parallel lines, and a tangent, right? Now for angle C, how can we find it? Now the only way that I see ourselves, like the way I see ourselves finding it, it's quite easy. So for starters, what we're gonna do, let me remove this. We're gonna say angle E is equals to angle A2. Why? Angles in the same seg. Okay, so angles in the same seg. So this means that both of them are equal to each other, and we do know that angle E is equals to X. Why? Parallel lines, right? So this is parallel lines. You see, Z, they alternate, right? So resin alternate angles because of AB being parallel to ED. Perfect. So this means that angle A2 is also equal to x, if that's what we say. Okay. Now, from there on, we can then use tan chord for B to find angle B2. So angle B2, we're going to say angle B2, it is going to be angle B2 is equals to x plus y, tan chord. I'm sure someone now is following along. So for those who are lost on what is it doing and what am I trying to find here, is what I'm trying to do is to find at least two of these angles, angle B2 and angle E, so I can use the sum of angles in a triangle to find angle C. So that's why I took that route. I hope everyone understands that. Okay, perfect. Now, since we know that angle E is equals to x, then we can just do the sum of angles in a triangle and say angle C plus angle B2 plus angle E, right? We have to be specific which E, because you can't just say angle E, because are you talking about this E or what? So we're going to say, we're going to use the acronyms of, and this one's going to say BEC, okay, which is equals to 180 degrees. And angles in the sum of angles in a triangle, yeah, angles in a triangle. Then angle C is going to be 180 degrees minus x minus y, this one B, then our E minus x. Okay, then we have 180 degrees minus 2x minus y, which is the answer for C. They said in terms of x and y, they didn't say or. Okay, so yeah, we found the first one. That was easy, right, guys? It looks intimidating, but so far we've done the first part of the job. Okay, now let's move on to the next question, which is 17.3.2. This one here. Now this one is an argument between two students, Becky and Teboho, right? So they're arguing on the basis of is B, C, D, F a cyclic quad, right? So that's what they're arguing about. Now Becky says that it is not a cyclic quad, while Teboho insists that it is a cyclic quad, right? So we have to reach a conclusion. So we are going to be helping them to reach a conclusion on whether or not this is a cyclic quad. Now the main thing that we have to know if we want to prove it's a cyclic quad, we know that we are going to be using what? B, B, E. Like I said in the video that I made, if you haven't checked it out, please do check it out. We are going to be using BBE, which is box bow tie extension. So we are going to be using this. Now this one, it summarizes everything, right? It's more of like the types of cyclic quads. Okay, so now which theorem are we going to use between the bow tie and the box and the extension? Now we can see that we don't have an extension coming out of, we do have an extension here coming out of this cyclic quad. Now we could basically prove that this angle here is equal to the interior opposite here. Now if they are not equal, this means Becky is correct. Or we could use a much simpler way, which is the box. Instead of using the extension, we can use the box, because the box will make us reach the conclusion much quicker. Of which, what I'm saying is, how about we prove that this angle in here, when you sum them up, they don't give you 180, right? Because remember that all the opposite interior angles of a cyclic quad are supplementary. Now, if they are not, when you sum them are not equal to 180, then this means that it's not a cyclic quad. Now we can go on and prove it long and long and long. We could do it like we have a lot of time. But then the issue is, in the exam room, you won't be having the time that you have right now as we are doing this problem together. Okay? So I'm going to do it two ways. Now the first one, let's use the box, meaning that's supplementary. Now, let's move on. So, we do know that, let me use my highlighter, A, B, F is a triangle, right? So since it's a triangle, it has an exterior angle, which is, now this is the, sorry about that. Now this is the exterior angle, okay? So this means the sum of the interior angles, we're going to get what? We're going to get BFD, Okay, is it BFD? Should we call it BFD? Yeah, I think it's fine. Yeah, BFD. Okay, so that's what we're gonna do. We're gonna say angle BFD is equals to 2x. Why? Exterior angle of a triangle. Now, since we have written that, we now have this angle here. Now, remember that we have C that we have proven before. Now we just have to add them and see if they can give us 180. If they don't, then this is not a cyclic quad. Let's do it right now. So we're going to say angle BFD plus angle C, plus angle C, they must equal to 180 degrees. And this is 2x plus 180 degrees minus 2x minus y. Okay, now obviously from the looks of it, 2x and 2x are going to cancel, and we're going to be left with 180 degrees minus y, which is equals to 180 degrees, which is not equals to 180 degrees. Okay, so this means that the opposite angles are not supplementary, proving that Becky is correct. So this means that Becky won the argument between is BCDF a cyclic, is BCFD a cyclic quad. Now Becky said it's not, so Becky won. Now the other way that we are going to do it is, since we know that A2 is equals to X, since it's proven above, we're going to say X here. Now we're going to look for this one here, which is going to be what? 180. The sum of angles in a triangle. We're going to use the sum of angles in a triangle. Let me show you guys. So you know that if we add them up, if we're looking for BFA, when we are looking for angle BFA, we're going to get the answer to be 180 degrees minus 2x. Now you can see that here it's equals to 180 degrees minus 2x minus y. And this one, it's not equal to, it doesn't have minus y. Let me use a red marker. It doesn't have minus y. So it's not a cyclic quad. So that's also using the extension, right? So yeah. So guys, we've reached the end of this video. I hope you enjoyed this one. It was quite impactful, and make sure that you do your revision, because it's mainly important that this year paper 2 doesn't scare us. And like that, guys, I will see you in the next one.